More on systems of three equations. We did some a few lessons back, and we're going to do some more today. So today we're actually going to be focusing on the second method of doing this, and then I will do one where we review the method that we did first. So if we have a system such as this one, our objective, of course, is to get numbers for all three variables. But to do that, the process is we need to get two equations with the same two variables because we know how to solve systems of two equations. What we are going to do today that is a little bit different is we are going to start with elimination to get there. So we are going to pick two equations and get rid of a variable. And then we'll pick a different pair of two equations, but we have to get rid of the same variable. That's the whole trick on it. So if I take these two, will my z's cancel out? And so if I just add these two rows together, 3x plus y, the z's go away, equals 4. Check my work on that. Does that look right to you guys? Okay, now I need to get a different pair. Well, I only have one equation I haven't used so far, so I have to use that third equation and one or the other of the two that I've just used. And I have to get rid of the z again because I just got rid of a z. So I must use this one. And how many think the middle one will be the easier one to use with that to get rid of the z's? Raise hands. How many think the first one would be easier to use with the bottom one to get rid of the z's? Okay, most people voted for the second one. And I'm going to agree with that because if I take the second and the third, the z's will cancel out like they are. If I took the third with the first, I'd have to multiply one of them by a -1 to make the z's cancel. Would not be wrong, but I'd have to do that extra step. So if I take these two and put them together, what do I have? 4x minus 3y equals 1. Questions from anybody there? So we got rid of the z both times. So now we have two equations with x and y. Do you know how to solve a system like that? I better see every hand up right now. You've been doing these for a while, not just this year. Either substitution or elimination, your choice. I'm going to pick substitution just for the heck of it. And since I have a 1y already. So y is 4 minus 3x. Plug that in for this y. And you go ahead and do that individually in your notebooks. So you guys just told me that on your own you got x is 1. Let's see if I can catch up to that. 4x minus 12 plus 9x is 1. Add 12 to both sides and I have 13. Combine the x's. So it looks like I'm also getting x is 1. We still need y and z. So we come back up. Where do you want to go to get y or z next? Somebody give me an idea of what we can do. Thanks, Bryce. Okay, I'm going to substitute x into which equation? Because I've got a whole bunch up there. Okay, so we're going to bring it up here and say y is 4 minus 3 times 1. Everybody shout out what's y. Okay, now I've got x is 1 and y is also 1, and I need z. Where do I go to do that? Charlotte, where should I go to get z? So the first one of the original printed ones, and I could go to any of them. This works as well as any. So x is 1, y is 1, plus z needs to be 4. So 3 plus z is 4. I feel like we're in a rut. Z is also 1. Not okay to leave it like that. We're going to write it as a triple. So parentheses, x was 1, y was 1, z was 1, and there is our answer. And do we have any questions on that one? Charlotte, are we going to learn what? Matrices, no. That comes next year, but we do not do, even next year, we don't teach the matrix method specifically, or the calculator matrix method of solving equations. We do learn Kramer's rule, which uses determinants of matrices next year. So things to look forward to, coming attractions. All right, this one, let's review the other method that we had, that we've already done. Our objective is still the same, get what x, y, and z are, and do that by first getting two equations with the same two variables. The method that we already learned was start with substitution instead of starting with elimination. So I need to pick one of these and get x equals, or y equals, or z equals. And my first equation, I have an x I could get by itself. My second one, I have an x, a y, or a z I could get by itself. I'm going to pick the second one just because I have smaller coefficients all the way across it than I do in the first one. And it would be totally okay to do x equals, or y equals, or z equals on that. I'm going to choose x equals 3 minus y and plus z. With the substitution method, you pick one equation to isolate the variable, and then you have to substitute that into both of the other two to get the system that you're going to solve that just has two equations and two variables. So I put that into the top one. I have 3 minus y plus z, and then I have the original minus 2y plus 2z is 2, and I'll need to clean that up. And I plug it into the bottom one, and I have 3 times the 3 minus y plus z, and then the original minus 2y minus 2z equals 2. Everybody okay there? Thumbs up, thumbs down, everything looking okay so far? Okay, now let's clean it up. So let's get our constants together. Let's get our y's together. Let's get our z's together. And we're used to doing them with something times one variable plus or minus something times another variable equals the numbers. So I'm going to get the numbers all on the right-hand side. So let's see, what does that mean I'm going to have? Minus 3y, actually I think I'll put it over here a little bit, minus 3y and plus 3z and equals negative 1. Did I do that at all right? Yes, no? I don't even have this written down on my paper. Are we good? Help me out here. Thumbs up or thumbs down or questions? Everybody's getting the same thing? Okay, then for the bottom one, let's see. I need to do some distributing first. So 9 minus 3y plus 3z, and minus 2y and minus 2z is 2. And then if I clean that up, how many y's do I have? Negative what? Negative 5y. And what about my z's? Just 1? And then subtract 9 on both sides, negative 7. This does not look like a very nice system. Is that what you guys are getting? Okay, but this is now the system that I need to solve. Two variables, which are y and z, two equations. Now, do you want to do that one with substitution or elimination? Give me a vote. Hands up for substitution. We could do z equals. Hands up for elimination, probably multiplying by a negative 3. Few more hands on elimination, so we'll do it with elimination. So that means I'm keeping my first one, negative 3y plus 3z is negative 1. And multiplying that one by negative 3, is that what you guys want to do? The easiest, get rid of the z's? So if I multiply that by negative 3, positive 15y minus 3z is positive 21. Finish it from there. You guys just told me you got 5/3 for y, so let's see if I can agree with you. 12y is 20. Dividing by 12, divide top and bottom by 4. I am also getting 5/3 for y. So now we've got to get back where we can see our equations. And where do we want to go for y? If we plug that in on any of these original ones, is that going to really let us get where we need to be? Those will all still have x and z, right? So we need to come to probably one of these equations that I wrote in purple. Which one would you rather put y into to get z? Anna? So Anna's picking the top one. You could use either. They're both totally fine. So we're going to take minus 3 times the y that we just got, which was 5/3, right? Plus 3z is negative 1. So this becomes a negative 5. Add that to both sides. And I have 3z is 4. So z is 4/3. Are we good there? So now we have y and z, and we need to pick one of our original equations to get x. So one of these three. And Hendrix, which one would you pick? Okay, I agree. It's got the smallest numbers, so let's pick x plus y minus z is 3. And we're going to plug in what we have. So x plus y minus z is 3, I think is what I just said. And we're going to put these numbers in for x and y. So y was 5/3. Z was 4/3. So let's see, I have x plus 1/3 is 3. So subtract 1/3 on both sides. And x is 2 and 2/3, or 8/3. And I'm not quite finished because we're not going to leave it x equals y equals z equals. We're going to write it as a triple. And we have to make sure we get them in the right order. X was which one? 8/3. Y was which one? And z was which one? And I did change my x to 8/3 since my other two were already improper fractions, and that way I was just consistent. Anybody with questions there? All right, summary, and write this in whatever short form works for you. If we want to solve a system of 3 equations with 3 unknowns or 3 variables, our objective is to start with 2 equations with the same 2 variables. You have a choice, which is basically, do you want to start with substitution or with elimination? Depending on the system, sometimes one is easier, sometimes the other is easier. If you do substitution, you pick one equation and isolate the variable, and then you plug that into both of the other 2 equations. If you pick elimination, you take 2 equations and get rid of one variable. Then you keep one of those and take the other equation that you haven't already used and eliminate the same variable. That's the trick. Then either way, you have 2 equations with 2 unknowns, like I have down here at the bottom. Then you do substitution or elimination to get your next variable, and then substitution to get your final one. Questions from anybody on any of that today?